Hi everyone, in this video I'd like to talk a little bit about parametric equations and tangent lines. So in this exercise we're going to find the tangent line to the curve at t equals 1. So I'm just going to emphasize that piece of information, t equals 1, and plot both the curve and the tangent line. All right. So first of all, let's take a look at what is a parametric curve. And once we've got a picture of this curve, then we can think about where the tangent line might be and how to compute it. So I think the best way to get an introductory understanding of this is to look at a plot, and I'm going to actually make an animated plot. So I'm going to hop over here to Desmos. Okay, so the first piece of information they gave us is they gave us information about X and they gave us information about Y. So instead of plotting, like X, Y, like over 1 up to, instead of plotting like X, Y coordinates, I'm going to plot a function that determines my X coordinates, and that function was square root t. And then for the Y coordinate, the Y movement was dictated by a different function, which was t minus 3. So this is what's really cool about parametric curves, is that you can have one function describing what's happening in the X direction and another function describing what's happening in the Y direction. And so you can get all sorts of spirals and squirrely behavior, things that you couldn't even model with a regular old function, can be really nicely modeled with parametrics. All right, so t, I'm going to let t go from 0 to 100. I might drive off the graph, but I don't care. Maybe I overdid it. I can do 30. Doesn't matter. You can play around with those numbers. So it looks like I kind of have half of a parabola, perhaps. But notice that t starts at 0 and goes up to 30. In other words, there's some sort of starting and stopping behavior. There's some sort of direction of travel along this curve. So if you want to animate the plot in Desmos, instead of plotting t's, you're going to plot in the parameter a. And then it says, do you want to add a slider for a? And yes, we do. So I'm going to click that, and let's start off a at 0. Where's 0? 0 to 30, step of 1, that's fine. Okay, so here we go. So when a is 0, I can see the point showing up on my curve. And as I slide this along, I can see the direction of travel. So when you do your homework, you will have to indicate an arrow showing the direction of travel. So if you were modeling like a space probe or maybe an insect's movement, if you were an ecologist, you could do that quite nicely with parametric equations. Okay, so our next task was to figure out a tangent line. So once we've got our parametric curve, we know a tangent line just hits it at one spot. So let's go back over here. So I'm just going to put a check mark next to what is a parametric curve. I haven't formally defined it, but I've given you a visualization. So I think you probably have a good sense of what it looks like. It's a curve. We've got a parameter. The parameter starts and stops somewhere. We've got a direction. So let's do our tangent line. So to find the tangent, we've got step 1. Find your x, y coordinates at t equals 1 in this case. So when t equals 1, x equals the square root of 1, and y equals 1 minus 3, which is a negative 2. So my point of interest is 1 comma, negative 2. So if I go back to my plot, I could add a point here over 1, negative 2. And I could label that P if I wanted to. That's my point. And again, you can see with your slider bar, as you slide it over, when your parameter there equals 1, you landed on that spot. So we could find tangents at different spots, but I'm interested in this particular one. When t equals 1, my x, y coordinates are 1, comma, negative 2. All right, back to the drawing board. That was step 1. Now, step 2, come over here so we have some space. Find your slope. And we talk about slope, that's our m coordinate. So to find the slope of a tangent line is given by the derivative. So the slope is going to be dy dx. Now, I don't really have dy dx, but I can certainly do dy dt all over dx dt, and then I can evaluate that at my point t equals 1. All right, so first of all, dy dt is just going to be 1, and dx dt, the derivative of the square root function, is going to be 1/2 t to the negative 1/2 power. You could simplify it, but I'm not too worried about that right now. So when t equals 1, our slope is m equals 1 over 1/2, which is 2. Lastly, your third step is to write the equation of the tangent line. So we're going to go y minus y naught equals m times x minus x naught. So I've got a point. I've got a y coordinate for my point, which is a negative 2. I've got an x coordinate for my point of interest, which is 1. And now I know my slope, which is 2. I've computed all those pieces so far. So really step 3 is just putting it all together. So I've got y minus a negative 2 equals 2x minus 1. And if we clean that up, that would be y equals 2x. And then distributing here, we get a negative 2. Bringing over the other 2, we have 2x minus 4. So now the very satisfying part of these problems is you can come over to Desmos and plot your tangent line, and then you know you did the problem right. Now, you can further tidy up your plot, and I like to do this just because now we've got a lot of lines on here. I like to make my tangent line dotted. You don't have to do that, but you can if you want to. I just think it makes it clearer. And then maybe the original function, like our parametric curve, maybe that one here, we could make it really bold, you know, like a really heavy line. I don't know. Something like that. Again, I'm just playing around at this point, but you get the idea. I will share this link with any of my students. Enjoy.